Hello everyone, I am Dr. Sirajul Hafizi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about previous year questions. Question is old, but this type of questions always important for 12th examinations. So I will start with very short answer type questions, 1 mark. Like this. What is the formula of a compound in which the element Y forms CCP lattice and atom of X occupy 1/3 of tetrahedral. How you answer? So, since Y forms CCP, this Y forms CCP, therefore Y is equal to 8 into 1/8 is equal to 1. Okay. Also, since X occupies 1/3 of tetrahedral wide, so X is equal to 1/3 into 2 is equal to 2/3. So, ratio of formula of compound X 2/3 Y1. Okay. Now, what is the formula of compound in which Y forms CCP lattice and atoms of X occupy 2/3 of tetrahedral wide? Same, Y forms CCP, therefore Y is equal to 8, 1/8 is equal to 1. X occupy 2/3 of tetrahedral wide, therefore number of X is equal to 2 into 2/3 is equal to 4/3. So ratio X 4/3 Y1, that is X4 Y3 is the formula of compound. Okay. Now, what is the formula of compound in which the elements Y forms CCP lattice and atoms of X occupy 2/3 of octahedral wides? So, number of Y in CCP is equal to 8 into 1/8 is equal to 1, and number of X is equal to 2/3 into 1, 2/3. So, ratio X 2/3 Y1. So, formula just like this, X4 Y3. So, here you have the X2 and Y3. Now, name the type of crystal defect which is produced when sodium chloride crystal is doped with magnesium chloride. So, cation vacancy defect or non-stoichiometric defect, impurities defect, like this. What is the formula of compound in which the element Y form a CP lattice and atoms of X occupy 1/3 of octahedral wide? Same, Y is equal to 8 into 1/8, 1, X is equal to 1/3 into 1, 1/3. The formula of the compound X 1/3 Y1. So, that is XY3 is the formula of compound. Okay. What types of stoichiometry defect is shown by silver chloride? Silver chloride shows Frankel defects. Now, short answer type questions, 2 marks. The compound copper chloride formula 99 gram per mole has FCCP structure like zinc sulfide. Its density is 3.4 gram per cubic centimeter. What is the length of age of unit cell? You know, Ne is equal to 6.02 into 10^23 per mole. So, answer is, in FCC, you can see the 4. You have the formula D is equal to Z into M, A cube Na. A cube is equal to Z into M. Density is equal to Na. You can put all values here, do the mathematics. Then this value is coming for A cube. Now calculate A, and then A is coming in different unit. So your one unit is picometer. Then you have the X is equal to this. This is the mathematical formula. So you know log X 1/3, log 93 in this one, and then antilog. Now friends, an element with density 10 gram cubic centimeter forms a cube cell with edge length of 3 into 10 to the minus 8 centimeter. What is the nature of cubic unit cell if the atomic mass of the element is 81 gram per mole? So whatever information provided in these questions, you can just adjust, and what is you have the calculation. So Z is equal to D into A cube into Na divided by M. So average is given, you just put it the values and 2 is coming, so it has BCC structure. Now define the following: primitive unit cell, Scotty defect, and ferromagnetism. You know the primitive unit cell means the cell in which particles are at corner only. A Scotty defect means it is due to missing of cation and anion from their position. Ferromagnetism means the magnetic moment are permanently aligned in same direction. It has permanent high magnetic moment. Next important question: define the following: F center, P center, semiconductor, and ferrimagnetism. You know the F center, anion vacancy occupied by ferrite electrons as in alkali metal halide, and P-type semiconductor means silicon and germanium doped with trivalent atom, creating electron vacancy. Positive hole increases electrical conductance. And the last ferrimagnetism is magnetic dipoles are aligned parallel and anti-parallel but unequal in number, leading to a small magnetic moment. Now you can see, examine the given defective crystals. So answer the following questions. Is the above defect stoichiometry or non-stoichiometry? Right term used for this type of defect. Why do silver halides show this type of defect? Now it is showing first answer is that above stoichiometry or non-stoichiometry? Stoichiometry. What types are used for this type of defect? Frankel defect. It is because silver plus and X minus differ appreciably in their size, where X represent any halide. Now define the following: crystalline solid means Frankel defect and N-type semiconductor. So what is Frankel defect? What is crystalline solid? So crystalline, those solid which have 3D arrangement of atom, ions or molecules are called crystalline solid. Example, diamond. And this is due to the shifting of ion from its normal position to an interstitial in the crystal lattice, and thus causing a vacancy in the original position. The overall density is not affected by this change. This one is Frankel defect. N-type semiconductor means when group 14 elements like silicon, germanium are doped with group 15 elements like arsenic and timmy, we get N-type semiconductor. This type of answer you have to write. Now define the following: Scotty defect, Frankel defect, F center. So you have the answer in questions 9. Say already discussed about this. Now this question you can see: an element with molar mass 27 gram per mole forms a cubic unit cell with edge length this. If its density is 2.7 gram per cubic centimeter, what is the nature of cubic unit cell? So what you have to calculate: first you check the data. You have M, you have don't know the Z, you have A, you have D. So D is equal to this formula. So all formula you can put. Z is equal to this value. Then you will get the 4. It has FCC structure. Like this you have to answer. Examine the given defect crystals. Same way. Answer the following questions. Is above defect stoichiometric or non-stoichiometric? Write the term used for this type of defect. Give an example of compound which show this type of defect. How does this defect affect the density of the crystal? So answer, it is a stoichiometric defect, a Scotty defect. Sodium chloride show this type of defect. Density crystal decreases. Density of crystal decreases. Now the next questions: an element's X mass given has a density this one. Identify the type of cubic unit cell if the edge length of the unit cell is this. So answer, Z rank of the unit cell, molar mass M 60 gram per mole, edge length this one, density, everything is same. Whatever question given, then you will calculate the value of Z. Therefore unit cell is FCC, face centered cubic. Now examine the given defect crystal like this. Answer the following question: is the above defect stoichiometric or non-stoichiometric? Write term used for the electron occupied side and give an example of compound which shows this type of defect. So you have the non-stoichiometric, F center, and lithium chloride is heated with lithium vapors. It shows and this type of defects. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.